Today we're going to use what we know about two-way tables to make two-way relative frequency tables. You should be on page 13 in your notes packet. A relative frequency table is a two-way table that shows the popularity of certain data in the form of a percent or as its decimal equivalent. In this two-way table here, you can see that you have a total of 100. That indicates that this is actually a two-way relative frequency table. What this does is it shows us the relative frequency in terms of a percent. So in this case, this number is 33. That doesn't mean that there were necessarily 33 people here, but what it means is that 33% of the people surveyed would have had an answer of Northside and Jensen. 23% of the people surveyed would have had an answer of Southside and Smith. 60% of the people surveyed would have had an answer of Northside. So you can see how you can take a relative frequency or a two-way table and make it into a relative frequency table. This next table is not actually a relative frequency table, but it is showing you how you can get to that. So in this case, it's showing that we have two people who have a high school degree. Well, that is out of 40 total people. So to turn that into relative frequency, you can say 2 out of 40 as a fraction, and then change that into a decimal by doing 2 divided by 40. When you do that, you get 0.05, which you see here. Well, you can change 0.05 into a percent by moving the decimal 2 places to the right. And when you do that, you're going to get 5%. So whenever you have a two-way table, you can just change it into a relative frequency table by either making it decimals or percents. Let's look at your first example. This says Ms. Johnson's class collected data on whether or not they have a curfew on school nights and whether or not they have assigned chores. The two-way table displays this data. So you can see in this two-way table that there was a total of 30 students surveyed for this. What we can do is we can take that table and we can make a relative frequency table out of that data. So let's start with 12 people who have both a curfew and chores. Well, we know that that is 12 people out of 30 total people. I would divide 12 by 30, and that's going to give me 0.4. So I'm going to put this as 0.4. I could have chosen to put this as a percent in my relative frequency table, and if I did that, I would have moved my decimal 2 places to the right, which would have left me with an empty space here that would have had to be filled in with a 0. So 0.4 is the same as 40%. So that means that 12 students surveyed had a curfew and chores, and that meant that 40% of the students who were surveyed had both a curfew and chores. Now let's look at no curfew and chores. Well, that is 3 students out of 30 total. And if I do 3 divided by 30, I get 0.1. So I'll put 0.1 into my relative frequency table. And again, this could have been written as a percent. And to do that, I would have just moved my decimal 2 places to the right, which would have given me 10%. So only 3 students have no curfew and have chores, and that represents 10% of the students who were surveyed. Next, I have 5 students who have a curfew and no chores. Well, that is 5 students out of 30. If I divide 5 by 30, what you're going to notice is that we have a repeating decimal. The 6 repeats. Well, if I change that, well, first off, I can put that into my relative frequency table. But secondly, if I change that into a percent, I would move my decimal 2 places to the right. My new decimal would go here, but we have to remember that this 6 repeats. So I would have a percent that would be 16.6 because there is still this repeating 6 behind it. Next, I have 10 students who have no curfew and no chores. So that's 10 students out of 30, which if I put that in my calculator, gives me another repeating decimal. So that's 0.3 repeating. Again, if I move that decimal 2 places to the right, I'm going to have a repeating decimal here in my percent. So it would be 33.3 repeating percent. Now for the totals, I can put 17 over 30. Again, that's another repeating decimal, but it's 0.56 repeating, and only the 6 repeats, so I only put the bar over the 6. If I were to change that into a percent, that would be 56.6 repeating percent. Next, I have 13 over 30. And when I change that, I get 0.43 and the 3 repeats. So if I change this into a decimal or into a percent, it would be 43.3 repeating percent. Now, this relative frequency table over here doesn't have a total row, but we can add one because what you'll see is that over here, this total is going to be 100%. So the total in all is 30. Well, that's 30 students out of 30 total students. That is 1. 1 whole is actually 100% if I were to move that decimal. So it would really be 100% of the data. And that makes sense because that is the total number of students who were surveyed. Then I have 15 for my total for chores. So that is 15 over 30. If you put 15 divided by 30 into your calculator, you're going to get 0.5. And if we move that decimal two places to the right, we're going to get 50%. Well, the next one is also 15, so I'm going to get that same number there. And you can see that when we look at this, 50% of students have chores and 50% of students have no chores. But then when I look at what's happening with my curfew as well, I can see that if I look at a student who has a curfew and has chores, 40% have a curfew and chores. And then if I compare no curfew to no chores, you can see that that's right here. Well, that is 33.3% of students have no curfew and no chores. Now, what you can see when you're looking at the people with curfews and no chores, that's about 16.6% of people. And no curfew and chores is about 10% of people. So you can see that these two are not very large when you're looking at percent of the population overall. But with this question right here, it asks, is there an association between curfews and students having chores? Well, we see that 40% of students have a curfew and have chores. And then 33% of students have no curfew and have no chores. So you can see from the relative frequency table that by putting it in terms of percents, you can see a relationship sometimes more strongly. So in this case, I would say that there is a relationship, and it seems to be that students with curfews tend to also have chores, while students without curfews tend to also have no chores. Now let's look at an example of a frequency table. This says a survey of voters explored the relationship between the ages of voters and whether or not they support building skateboard ramps at a local park. Number 1 says what percentage of surveyed voters in the 58 and over age group are opposed to building skateboard ramps. So we're looking at the 58 and over age group, and we're looking for those who are opposed. So here's 58 and over, and here is opposed. So you can see that that is 44 people. Now, that is 44 people out of 50 total people in that age group. Because this problem was asking us about just the 58 and over age group, instead of asking us about the entire population, we would be comparing the 44 who are opposed out of the total number of people in the 58 and over age group. If we do 44 divided by 50, we're going to get 0.88. Now, if we change that into a percent, we would move our decimal 2 places to the right, which would give us 88%. So our answer here is going to be A. Number 2 says which is not a reasonable interpretation of the data. And that word not is going to be very, very important when we're answering this question. So let's look at A. A says if we ignore age groupings, about the same number of total voters favor building skateboard ramps as oppose it. So if we're ignoring age groupings, then that means we're looking at the totals. Well, when we look at the totals, we can see that 73 approve while 77 oppose. Well, this says not the same number, but about the same number. And 73 and 77 are fairly close to each other. So I would say that yes, this is a reasonable interpretation of the data. So that would not answer the question because we're looking for one that is not reasonable. B says voters in the 18 to 37 age group are much more likely to favor building skateboard ramps than to oppose it. So we're looking at the age 18 to 37. Well, we're looking for those in favor and those who are opposed. So it says there are 40 who are in favor or who approve, and there are 10 who are opposed. Well, this says that they are much more likely to favor building the skateboard ramps. Well, we see that this is 40 who favor it and 10 who don't. Well, that is a very big difference. So I would say that this is also a reasonable interpretation of the data. So again, that does not answer the question because we're looking for one that does not. C says voters in the 38 to 57 age group, so we're looking here, are much more likely to favor building skateboard ramps than to oppose it. So again, we're looking at favored and opposed. So we see that there are 27 who favor it, and there are 23 who oppose. Now, when we look at this, we can see that they are more likely to favor it than to oppose. But when we look at this answer, it says that they have to be much more likely to favor it. Now, 27 and 23 are actually fairly close together. So we wouldn't say that that is much more likely. It is more likely to favor, but it's not a lot more likely. So C does not seem to be a reasonable interpretation of the data. But just to make sure, we want to check D to make sure that D is reasonable. D says that voters in the 58 and over age group, so we're looking here again, are much more likely to oppose building the skateboard ramps than favor it. Well, when we look here, we see that there are 6 who favor it, and there are 44 who oppose. Now, this says that they are much more likely to oppose, and I can see that 44 people opposing as opposed to 6 people favoring. That is a big difference. So yes, they are much more likely to oppose those skateboard ramps than they are to favor it. So this again is a reasonable conclusion. So that means that C is going to be our answer that is not a reasonable interpretation of the data. Next, you see that Jamie wanted to know if there is a relationship between the type of sports played and the grade the student is in, so he surveyed 100 students at his middle school. His results are displayed in the 2A relative frequency table below. Well, when you look at this relative frequency table, you can see that all of these numbers are decimals. That tells us that obviously there are not 0.15 people in 6th grade who like soccer. What this is a decimal equivalent of the total, comparing it to the total population. So what we see is that there are 0.15 6th grade students who like soccer. Well, that means that 15% of the people who were surveyed were in 6th grade and like soccer. We can see that this number right here means that 8% of the people surveyed were in 7th grade and like football and play football. So let's look at these problems. Number 1 says out of all the students, 44% chose this sport, making it the most popular sport. Well, because I'm looking for out of all the students, I'm going to be looking in this total row. I'm looking for the total that has 44%. Well, I can see that that occurs right here. And the sport that occurs with is soccer. So that means that 44% of students chose soccer. Number 2 says out of all the students surveyed, 35% of them are in this grade. So grades are over here, which means I need to look in the total over here because I'm looking again out of all the students surveyed. So I'm looking for 35%. Well, I see 35% occurs right here. Well, that goes with 8th grade. So 35% of the students who were surveyed are in 8th grade. The sport played by the least amount of people or of students is what? Well, again, sports are over here, so we're looking in this total row. Well, 44% of students play soccer, 29% of students play football, and 27% of students play baseball. Since this number is lower, that means that there is a lower number of students who play baseball than any other sport. Then number 4 says this percent of students surveyed play football. So again, looking at total, and because we're looking at the sports, we're going to look down here. Well, when I look at football, football is right here. I'm again looking at all students. So when I look at the percent, I need to look down here at the total. Well, 0.29 is a decimal, but we know that to change it to a percent, we would just move that decimal 2 places to the right. So that would give us 29%.